Okay, here's how I did. I started by adding 2. I got 12 is equal to 3 times the absolute value of x plus 3. Then I divided by 3. I got 4 equals the absolute value of x plus 3. And then I got x equals 1 and negative 7. So hopefully I did that right. Let me see. If I put in 1 there, yeah, that works. So good. Awesome. Okay, I'm going to just take a quick side trip here and start exploring some special cases. The special cases is when you have a negative on the other side of the absolute value. Now, an absolute value always has to be positive. So it doesn't matter what's in here. If I say the absolute value of anything equals some negative number, that's the empty set. That's no solution. Oftentimes we'll do this. We'll draw a circle like that with a slash through it. That means the empty set. That means no solution. So when you have no solution and you write that for your answer, you look really smart. So go ahead and do that. Okay. For this one here, you have the absolute value of x is greater than negative 7. Well, an absolute value, when you're dealing with a negative, it's always going to be greater because this is always positive. And a positive is always greater than a negative, so this will be all numbers. And sometimes we use this fancy symbol. Okay, and you've probably seen that before. That means all real numbers. All real numbers. Try to actually fit that on the screen there. So what I'm saying is, well, is a positive greater than a negative? Yes, all the time. All the time a positive is greater than a negative, so that would be all real numbers. Finally, I have a positive is less than a negative, and again, that's a no solution. A positive can't be less than a negative number. No solution. Okay, we have these special symbols because it gets tiresome to write out no solution in all real numbers 176 times. So if you just have those symbols, that'll speed things up for you a little bit. So the special cases, I'm going to slide this up just for a second. The special cases are when you're dealing with the negatives. Okay, so when you're dealing with the absolute value and a negative, that's when you have no solution, all real numbers, or no solution, depending on the setup. But you can just think about it. You don't need to memorize all this. Can a positive equal a negative? No. Is a positive greater than a negative? Yes. Is a positive less than a negative? No. So you can just think it through and figure out what it is. It's not something that you'll have to memorize, which is cool. Okay, I'm going to look at an example of a inequality. So I have the absolute value of 2x plus 6 less than or equal to 4. Okay? In this case, you write this as a between inequality. Okay? Because if the absolute value is less than 4, it also has to be greater than negative 4. Because if this is like negative 5, the absolute value would be positive 5. That would be too much. So when you see a less than, it's just going to become a between inequality, and then we can solve that. So let me see. That's going to be negative 10, less than or equal to 2x, less than or equal to, that's negative 2. And then we will divide by 2. And you're going to see a lot of negatives here. Don't get too crazy with me, because I had our absolute value is less than a positive. That's okay. So the fact that we have a lot of negatives here at the end doesn't mean anything. Okay? So like x has to be between negative 5 and negative 1. So negative 3 should work because it's between those. Whoops, I cut off my screen. So that was my final answer. So a number in between, like negative 3, should work in the original equation. Let's check it out. So if I put negative 3 in here for x, well, 2 times negative 3 is negative 6. Negative 6 plus 6 is 0, and the absolute value of that is less than or equal to 4. So any number between negative 5 and negative 1, if I put it in here for x, will give me something that works out that's less than or equal to 4. That's what this answer means. Okay. For this next one, I'm going to call it a triad. Oh, actually, I should graph this. I'm sorry. So negative 5, negative 1, 0, fill in the circles. Sorry, forgot to do my graph. But graphing in between inequality is very straightforward. You just fill in between them. So I call it a between inequality. For this next try, I'm actually going to start you off. So when you have an absolute value greater than a number, we're going to kind of do the same thing. 8a is greater than or equal to 32. Whoops. And this is going to become an or 8a is less than or equal to negative 32. Okay? Because if this is less than 32, like if this 8a comes out to 40, if a was negative 5 or negative 40, when you take the absolute value, it is greater than 32. So a big negative number here is okay, because I'm going to take its absolute value, and then it will be greater than 32. So when the absolute value is greater, it becomes an or inequality. Go ahead and finish that off, and graph your solution.